The James Webb Space Telescope has accomplished significant advancements, providing an unprecedented look at the universe. This time, it has delved deep into the famous depths of the supernova. This telescope has revealed new structures in SN 1987A, structures that no one had ever seen before or viewed by earlier telescopes. In 1987, the star burst into flames, becoming the largest supernova visible from Earth in nearly 4 centuries. SN 1987A lies approximately 170,000 light-years away from us in a small galaxy with a massive Magellanic Cloud. Close to our own Milky Way, the new image, uniquely captured by the telescope, shows the structure of the center of the remnant of the supernova in the shape of a keyhole in shades of blue. Join us on this 170,000 light-year trip to the large Magellanic Cloud to discover all the particulars about the supernova SN 1987A's core. The core of the supernova is composed of the supernova's ejected gas and dust from the explosion, and extremely dense dust that even infrared light cannot access through a telescope. Constructing a gloomy keyhole within a keyhole, we find a bright equatorial ring that creates a band around the region's center and connects to faintly shaped hourglass arms. This equator-centered ring was made from debris ejected tens of millions of years ago, prior to the supernova explosion, with bright spots that emerged shortly after the supernova shock impacted against it. As per information from NASA, these spots that had been found formed when the shock wave, generated by the supernova explosion, hit the gas equator that the star had thrown away tens of millions of years prior to its explosion. These spots can now be seen outside the main ring, which diffuses light. These areas fit into their surroundings where the shock collides with both the wave and the surrounding material. Additionally, the Webb telescope has revealed additional crescent-shaped structures, which had gone unnoticed in previous observations made by the Hubble Space Telescope. NASA's press release suggests that these outermost formations are crescent-shaped, layers of gas ejected during the supernova explosion. NASA's press release on the supernova publication noted that, despite decades of research since the first discovery of the supernova, several unknown facts remain unsolved, particularly in relation to details about neutron stars that ought to have emerged following the supernova explosion, according to the space agency. The James Webb Space Telescope will keep an eye on the supernova in the future. The James Webb Telescope discovered an additional dying star in the Saturn Ring Nebula, which also demonstrates intricate structures corresponding to the final stages of a star's life. This bright nebula is located approximately 2,200 light-years away, observable through binoculars from Earth during clear summer evenings in both the northern and southern hemispheres. This observation should not be confused with one of the first images captured by the James Webb Space Telescope. International cooperation, referred to as ESSENCE, consisting of experts from numerous nations with expertise in planetary nebulae and other related objects, recognized the importance of making observations over the network to obtain important information. The Ring Nebula was chosen as an ideal target due to its perfect location in the field. That can be seen by the mid-wavelength infrared camera aboard the James Webb Space Telescope. This decision enabled the nebula to be explored at an unprecedented level of spatial specificity, which in turn helped decipher some of the mysteries surrounding planetary nebulae. Thanks to its array of infrared sensors, images could be taken by the James Webb that provide outstanding spatial resolution and spectral sensitivity amid the cosmic chaos. According to the release, the telescope, situated approximately 1.6 million kilometers, 1 million miles from Earth, had access to previously unseen details about the intricate structure of the nebula. When scientists first made a discovery, they were taken aback by the abundance of fine detail. They showed the bright ring that gives the nebula its name, comprised of approximately 20,000 dense hydrogen molecule clusters comparable to those found on Earth. A small band within the Ring Nebula contains emission from aromatic, polycyclic hydrocarbons, and complex carbon molecules. This finding is surprising in that we did not anticipate finding these atoms that make up the Ring Nebula outside the bright ring. We observed particular peaks that run in opposite directions from the central star. These peaks stand out especially well in the infrared spectrum but are not as evident in visible images captured by the Hubble Space Telescope. It is believed that these peaks may be related to molecules that are capable of forming in the darker, denser areas of the ring, where the molecules would be protected from the intense radiation produced by the blazing central star. This includes a capture of infrared light, which cannot be seen by the naked eye. The James Webb Space Telescope provided detailed information regarding the ring's structure. Additionally, the presence of filaments, approximately 10 arcs in a circle, in the nebula's outermost regions was surprising. These target-shaped arcs imply that they formed approximately 280 years ago, when the central star, during this time, was shedding its outer layers, changing into a planetary nebula. This time frame is unusual, and an unknown process might be able to explain it. Instead, the presence of this ring indicates the possibility of a companion star in the system, which is orbiting at a significant distance from the central star, similar to the distance that Pluto is from our Sun. As the dying star dissipated its environment, the companion star might have influenced the formation of these strengths. Dr. West, of C University, offered a rationale for this phenomenon that has never occurred before. The telescope had the sensitivity and spatial resolution capacity to identify this important point. This is not the first time the James Webb Space Telescope has observed the Ring Nebula, highlighting the ongoing significance of examining this fascinating phenomenon. The Ring Nebula's past serves as a symbol of scientific and human curiosity, improvement over its earlier misinterpretations as a planetary nebula to the cutting-edge technology of the James Webb Space Telescope. Our quest to understand the development of this phenomenon has been closely tied to the Ring Nebula. Astronomy's development was found in 1779 by astronomers Charles and Cayman, who incorporated it into their thesis catalog when trying to follow a comet through the constellation Lyra. Today, this nebula has become an emblem of astronomical archaeology. Its distinctive ring, with lots of color, symbolizes the ashes of a dying star in the process of becoming a white dwarf, serving as an ominous reminder of our cosmic connection. In studying the Ring Nebula, not only are we observing a distant object, but we're exploring the universe's past, present, and future itself. We may even consider that our Sun, in about 5 billion years, could give rise to a similar nebula at the end of its life, though it is unlikely that we will be around to witness it. It is essential to know that the color differences between identical images of the nebula may appear odd. This is because the James Webb Telescope sees objects with wavelengths in the infrared, which are invisible to us. Webb images begin with a black background processor that translates them into visible light wavelengths, which highlights particular features of the nebula in each image. The James Webb Space Telescope's capacity to investigate everything, from the most in-depth perspectives on the universe to planets, rings, and our own solar system, is providing astronomers with a fascinating new perspective on space. What discoveries does the future hold with the James Webb Telescope? Inform us in the comments box what discoveries you would like the James Webb Observatory to make. If you enjoy the video, please hit the button to like and subscribe to the channel, and I'll see you in the next one. Many thanks for watching.